Hey, pre-cal, what's up? We're going to take it easy today. We're just going to watch a video, answer a few questions about the video. So let's get started. We're looking at Cramer's rule and the determinant of 3 by 3 matrices. All right, if you can do, well, a determinant is just a value. I mean, let's don't worry about the rest of that. It's just a number, a value, a number. And we've looked at that in 2 by 2s. We've set them up. And so setting up a 3 by 3 is not going to be any different. So if we set this system up to solve for y over here, then we want to take these numbers, the coefficients of the variables, keeping in mind all the equations are in specific x, y, z order. That's why we have focused so hard on standard form and specific order. And, they go here. So then it would be a matter of just copying that determinant to the top. And of course, that's not the answer because the answer to that would be 1. Anything divided by itself is 1. And then it matters that we're solving this for y. So we would take out the y coefficients in the numerator, and we would just replace them with these constants in order, 9, -4, 0. Okay, so see if you can answer. You might want to pause the video and see if you can answer that. All right, if I'm not mistaken, the answer is C. Let's get rid of all the distractors. I like to do that because it's so much fun. And even the top there. And then we just copy that to the top, and then we would put in, we're solving this for x. So we would put in the constants in the x column on top, 4, 6, 7. I believe that was the right answer. Okay, there's another problem. Number 2, see if you can identify that answer. I believe it is F. Okay, that the constants we're solving for z. The constants have to be in the z column on top, and everything else has to remain the same. All right, so you might want to pause the video and see if you could set that up for the variable z. I think I have it on the next slide. I'm not going to take the time to do that. All right, there you go. Then we kind of want to start with this side. Those, put them here, copy it to the top, and then take out the z column and replace it with the constants. All right, so the trick becomes, how do you find the determinant of a 3 by 3 matrix? There's actually 2 ways to do that. There's a cheap, unfulfilling way to do it, kind of like eating a Pop-Tart. And then there's the rich, fulfilling way to do it. And then that's the way we're going to look at it, is the rich, fulfilling way, kind of like creme brulee. Okay, a minor value. Let's take some time and let's look at that. Each element in a 3 by 3 matrix has a minor value. It is the 2 by 2 determinant, which we know, of the matrix left over after removing the row and column of the element. All right, and so the minor value of 3, we would make a 2 by 2 determinant of what's left over here, and everybody can do that. That would be 2 minus 24, which looks like -22 to me. Okay. All right, so see if you can do that. Number 3, what is the minor value that you may want to pause the video and see if you can do that. All right, so you would build, I'm going to build the 2 by 2s. So you would take out the row and column that 8 is in, and then you would build a 2 by 2 of what's left over, and then that's 9 minus 2 is 7. Again, you might want to pause the video. Minor value of 4 is -28. You take out the row and column that 4 is in, and you do that. So it'd be -30 minus -2 is -28. Minor value of 2. take out the row and column, and then the matrix would be -4, -1, 4, 0, and that looks like +4. It'd be that product, -4, minus that product. Whoops. I would start over, but I ain't. Let me start this problem over real quick. -4, 4, -1, 0. That product is 0 minus this product, -4 is +4. Okay, see if you can find the minor value of 0. All right, I didn't do this one at the bottom, so the determinant would be -4, -2, -5, 2. That product is -8 minus that product is 10. Looks like -18 is the minor value. So we can build. So again, if you want to pause the video and see if you can write a matrix of minor values for each element in the following matrix. Okay, I'm going to go ahead and jump to that. Let's test one value. Let's do the minor value of 1. And so that would be the leftover matrix is 3, 8, -3, -2. That product is -6 minus that product is -24. And so that looks like 18. And that's how we get that 18 right there. And you just do it for each one, each element in the original matrix. And then there's this thing called the matrix of signs. Okay, so we have a matrix of minors. Let me back up and point that out. We just did the matrix of minors. And then we have this matrix of signs, and it's kind of like we're overlaying it. Now, this isn't going to be that you take this matrix of signs, you overlay it to the matrix of minors. And what this plus means here is that you don't change the sign of 10. This minus means you change the sign of 18 and make it -18. And then the plus, this goes to a plus, so it stays +40. This goes to a minus, so it goes to +2. This goes to a plus, so it stays -4. And that's all the plus means. If it's a plus in the matrix of minors, then the element does not change sign. If it's positive, it stays positive. If it's negative, it stays negative. And if it overlays to a negative, it changes signs. If it's negative, it becomes positive and vice versa. So we have these two matrices now. We have a matrix of minors, which we could do on a test one day. We have a matrix of cofactors, which we could do on a test one day. And I want to take the matrix of cofactors and the original matrix of cofactors. And let's read what's up here. The determinant can be computed by multiplying the corresponding elements of any row or column in these matrices and adding the results. So if we do 2 times 10, we'd get 20 plus 1 times -18 is -18 plus 0 times 40 is 0. And the result of that is 2. So the determinant of the original matrix is 2. And it's any row in any column. Let's do another row. Okay. 3 times 2 is 6. -5 times -4 is 20. -3 times 8 is -24. So those two make 26, and a -24 make +2. Any row, any column. Let's do a column, I believe, next. Yeah. All right, 2 times 10 is 20, plus 3 times 2 is 6, plus 8 times -3 is -24. Kind of got some of the same numbers there. Let's do one more. Just for kicks, let's do one that isn't in here. Well, let's move this over. Let's do that column just to make sure that what we're saying is correct. All right. 1 times -18 is -18 plus 20 plus 0, 2. Any row, any column. It's pretty fantastic to me, actually. All right, that's pretty much the end of the video. I think we do have a cameo appearance today. Somebody asked me the other day, well, cameo appearance, what does that mean? Well, there's the definition by Google, is a brief appearance or voice part of a well-known person in a work of the performing arts. So, cameo appearance, drum roll. It is Carl from Sling Blade. He's got a message